In this podcast, you're going to learn how to name ionic compounds that contain polyatomic ions. So the first thing is, what is a polyatomic ion? Well, poly means many, and atomic means atom. So polyatomic is just an ion that has more than one type of atom. So examples of polyatomic ions would be hydroxide, which is OH minus, so it's got oxygen and hydrogen, so 2 atoms. Sulfate, SO4, with a charge of -2. Sulfite, SO3, with a charge of -2. And ammonium, which is actually the only positive polyatomic ion you have to worry about, which is NH4+. So when you're making a formula with ionic compounds that have a polyatomic ion, it's very similar to what we were doing before, but there's some extra rules. So when you have sodium and nitrate, which is Na and NO3, all you have to do, just like before, is cross the numbers. So you have 1 Na and 1 NO3. So that's your formula, NaNO3. Now the next one has a little bit of an extra step. Magnesium has a charge of +2, and ClO3 minus, which is chlorate, has a charge of -1. So you are going to still cross your charges. So you get MgClO3, but you're not just putting another 2 after the oxygen, because that would look like 32. You have to show that you're using the whole thing twice, so you do that by putting parentheses around it. So the parentheses show that the whole thing is used twice. And then again with this one, let's cross our charges. Now this time it's the beginning ion that's used twice. So you're going to put the NH4 in parentheses and put the 2 after it, followed by your 1s. So make sure if you're using the ion that has more than one element more than once, that you're putting a parenthesis and putting the number after the parentheses. When you're naming them, it's really pretty straightforward. Na is sodium. And all you have to do is look up SO4 on your ion chart. And SO4 is sulfate. So you just write the name of the ion. You don't even have to change any endings. Sodium sulfate. For the next one, Ca is calcium. And then on your ion chart, C2H3O2, that is acetate. So it's calcium acetate. Now, this one uses iron, which, remember, iron is a transition metal. So you have to figure out which form of iron it is. So iron can either have a charge of +2 or +3. So what we're going to do is we're going to bring up these charges so that you end up with Fe with a +3 and OH with a -1. Now check if on your ion chart the OH has a charge of -1, which it does, which means that this 3 is what you want for the iron. So this could be named either, in Roman numerals, iron 3, and then OH is hydroxide, or it could be iron 3 on the classical naming would be ferric hydroxide. And that's all there is to working with polyatomic ions. See you in class.